Okay, now let's go for the last case. Let's go and see the last case, the last thing which we will need to add to our common derivatives table, the table which we'll be using for the trig, guys. Okay, what is it? What is that last thing which we want to put? It's going to be the derivative of tan inverse of x. Now, if you remember, in Lipet, what did we have? Logarithmic, inverse trig, polynomial, exponential, and trig. So far, we've seen all these guys. We've seen how to do exponential, which is the e to the x. That's the one which we're doing with, and e to the f of x. We've seen logarithmic, ln x. We've seen how to do that. Okay, we've seen for trig, which is we've seen for sine x, we've seen for cos x, and we've seen for tan x. Okay, now we've seen polynomials. That was the first thing we did by power rule, right? X to the power of 5, we do the power rule. Okay, plus 3x squared. We know how to differentiate this guy. What about inverse trig? What about this, guys? Sine inverse of x, cos inverse of x, and tan inverse of x. Okay, what about this? Now I'll tell you. We don't do sine inverse of x. We don't do cos inverse of x. We only have to know tan inverse of x. Okay, because sine inverse of x and cos inverse are complicated for no reason. So we are only going to do for tan inverse of x. All right, let's go. Let's see how we would get the derivative. We want to get the derivative of tan inverse of x, right? All right, so we'll say first you must have this. Tan y is equal to x. Okay, let's first read. Let's start again. Let's say that we have y being equal to tan inverse of x. We want to find his derivative. So first, what would we do? If we take tan inverse to the other side, it becomes tan, right? Because if we know that if we say tan theta is equal to 30 degrees, to get theta, we take tan to the other side. We'd say theta is equal to tan inverse of 30 degrees, okay? Because when tan goes to the other side, it becomes tan inverse. So here, we are bringing him from the other side back to his original side. So it's going to be tan of y is equal to x, okay? It became from tan inverse, is now tan y is equal to x. Now, let's try to differentiate both sides, okay? Let's differentiate. This time we're differentiating with respect to x. d dx of tan y is equal to d dx of x. We're just showing you how we got to this, okay? We're just showing you how we got to the solution, not that you'd need it much. Let's see. What's the derivative of tan y? What's the derivative of tan y? Okay, so for this one, we know that to know this derivative, we're going to use a bit of the tricks from implicit differentiation, okay? Which says that if you're differentiating with respect to x and the thing does not have an x, what you do, you just differentiate it. So we just differentiated. Derivative of tan is secant squared. So it'll be secant squared y because it's tan y. But then you then multiply by dy dx. So it'll be 6 squared y dy dx. Okay? 6 squared y dy dx. And this will be equal to the derivative with respect to x. The derivative of x with respect to x is just 1. So now, what would I do when I have it like this? I'm going to say, you should remember this one, okay? You should remember this one to say, if I take secant squared, let's say I take secant squared to the other side, okay? I will have my dy dx, because that's what I'm looking for. It will be 1 over secant squared y, okay? But I know what secant squared is. What is secant squared? From the identity, do you remember the identity? We only have two. The first one says cos squared x plus sine squared x is equal to 1, right? Okay, but what is the other one? It says that 1 plus tan squared x is equal to secant squared x. So here, what is secant squared? It is 1 plus tan squared. So I can remove secant squared, right? I would say dy dx, it will be equal to 1 over, instead of secant squared, I can say 1 plus tan squared y, okay? I can say 1. So far I've gotten to this stage. Now all I want to do is to get the derivative, the dy dx. Now, what do I know about tan y? Why did I do this? Why did I take it back to this form? Because I know what tan y is. Tan y is just an x. So tan squared y is like tan y all squared, which is x squared. So I can say dy dx is just 1 over 1 plus x squared. Because I know that tan y is equal to x, okay? And here I've changed. So here I know that 1 plus tan squared x is equal to secant squared x. So I know that. That's how I change to this. Then I know how to change. So that is going to be your final solution, and I have it. And we know that 2 plus 3 is the same as 3 plus 2. So I can say that I can just write it as dy dx is equal to 1 over x squared plus 1. That's the way I like it. So now we already have it. So that means the ddx of tan inverse of x, it is just going to be 1 over x squared plus 1. Great job! So we can get it. ddx of tan inverse of x is 1 over x squared plus 1. Which means that if you were to be given ddx, okay, you can get it more complicated, of tan inverse 3x. What would it be? What is our x now? Our x is now 3x. So it will be 1 over 3x all squared, because he's our new x, right? 3x all squared plus 1. But then we must then multiply. Since this is not an x, it's a 3x. We must then multiply by the derivative. What's the derivative of 3x? It's just 3. So it will be 3 over 3x all squared plus 1. Okay, which we can expand to be 3 over 3 squared is 9. X squared is x squared plus 1. So it'll be 3 over 9x squared plus 1. We can have it like this. And you are done. That's your final solution. So we have done the last guy. And we can now put our table one more time to say y, then dy dx. Okay, we can bring that same table. Let's do it fast now. Sine x gives me cos x. Cos x gives me, if I differentiate it, negative sine x. Then derivative of tan x is secant squared x. Now we can put the same guys. Remember, we can put the same guys as sine of f of x. This is f dash x cos of f of x. Then here, cos of f of x, it is negative f dash x. Okay, negative f dash x. Then sine f of x. Then tan f of x would be f dash x times secant squared f of x. Then we do the last guy. Great, number 7. So what is it going to be? Tan inverse of x. This is going to be 1 over x squared plus 1. Okay, good. So what about for this guy? If there's just an f of x, if it's tan inverse of f of x, okay, some function which is not x, I'll put it for you right now. It would be, instead of saying times 1, you can just say it will be 1 over f of x all squared plus 1. Then the answer you multiply by f dash x. Okay, which is the same as saying f dash x over f of x all squared plus 1. Okay, you could also put it that way. And this is done. We have our things, and bravo!